by 2 square into dx. Okay, this is pi into by 2 square, because this is the closed curve here. The area of this is pi into by 2 square. Pi into by 2 square. Okay, that is the area here. Pi into by 2 square that I have taken here. Pi into by 2 square. Okay, this is the area here into dx. Area of the closed curve. If this closed curve is revolved about, this whole area is revolved about, then the radius of this circle will be this. So pi r square means pi into y2 square. Y2 is the length rq. Rq, where rq is y2. I'm sorry. This is y2 here. This y2 I have taken here. Minus sine of integration a to b into pi into y1 square into dx. Why? Because this lower part of this closed area, A, L, M, B, P. So P is the radius of this smaller area. Okay, this area we have taken, so y1 is there. So therefore the difference of this will be pi, if I take comma, A to B limits. This is y2 square minus y1 square into dx. This is first equation that we take. Okay, so this is y2 square minus y1 square we have taken, and dx, and pi outside. Okay, now what is the centroid of a closed curve here? Now if y bar is equal to, we know that if y bar is the centroid, length of the centroid, x bar, y bar, we know from centroid of a curve, centroid of a curve, or closed curve in this case, closed area, closed curve in this case, closed curve, in this case closed curve, G is the, if G is the CG, center of gravity, CG, center of gravity, this is center of gravity of this closed curve, so this is curve here, of this closed curve, and if x bar, y bar with the coordinates, x coordinate and y coordinate of this center of gravity G, x bar, y bar be the, okay, centroid coordinates कह सकते हैं. You can say this is centroid coordinates. With the centroid coordinates, with the centroid coordinates of this closed curve, then what do we know? This we know about, that this is the centroid, y bar is equal to, this y bar, if this is height of this, y bar is equal to half of, this is here, we know that this is half of y2 square minus y1 square into dx divided by s here. S is surface area. This formula we know. Now limits here are a to b of this closed curve, because this is lying between a and b, and G is the centroid of this curve. So a to b, this formula we have discussed in multiple integrals. Centroid, length of the centroid we have calculated, coordinates x bar and y bar we calculated there, and if it is x bar, then it is x2 square not y1, x1 square, difference of these two, upon s. S is the surface area of this closed surface area here, s is. Therefore this is twice into this 1.2, it is in here. So let me write it after multiplication. So from this what we get? This implies that sine of integration a to b into y2 square minus y1 square into dx is equal to s into ys, and this 2 will also come here. It is twice into s into y bar. So in place of this here, if I substitute this 2s into y bar, That will give us, therefore this is second equation here. First equation is this. This means this, sorry, this is the second equation here. This is second equation here. Alright, therefore this we know from center of gravity. This we have already discussed about the center of gravity. Y bar and x bar we have to calculate, and y bar is given by half a to b limits by 2 square minus by 1 square into dx upon s. S is the surface area of the closed curve in this case. In this case it is closed curve. If it's the length, then it will be L in the denominator, L into, and above it will be by minus by 1, or by 1 minus by 2. That will be there, or by length of, that means by into ds, that will be, okay, that will be calculated in second question. This is by bar here. So this, from this cross multiplication, this 2 and s will be multiplied. So 2 into s into y bar is equal to this value. This is equal to this twice s into y bar. Let me substitute this here in second, from first and second. What will we get? Therefore, from first and second, from first and second equation, we get that this volume of surface of revolution, volume of surface of revolution, volume of revolution, volume of revolution of closed curve about the line OX, straight line in this case, about the line OX, this is O point here, or the line OX is given by this pi as it is. In place of this we will write twice s into, this is 2 into capital S into by bar. Here capital S is the area of the closed curve. Area of the closed curve. This is area of the closed curve S. Therefore, let me first again illustrate this. Therefore, this is equal to, this I am writing here, this is equal to S into S, capital S if I take separately, this 2 pi into 2 pi into pi bar. What is 2 pi into pi bar? This is circumference of this closed curve. Okay, or I mean circumference of the circle generated by the centroid G. Let me write here. S is here. This is area of the closed curve into area of the closed curve. S is here. Area of the closed curve into, this is the first S here, into this length of the, or circumference, this is circumference of the circle, circumference of the circle generated by revolving this SG by bar. Circle, circumference of the circle generated by the centroid of the closed curve, by the centroid, G, SG, you may say SG in this case. Centroid is G, so we can say G, generated by the centroid G about the line, about the straight line. Okay, that is circumference of the ring or circle generated by this revolution, generated by the centroid about its line, about the line. Centroid, in this case, centroid of the closed curve, centroid of the closed curve, centroid of what? Centroid of the closed curve about the straight line, in this case, about the straight line of the substance. So this is circumference of the circle, circumference of the circle generated by revolving SG about this straight line, and that circle will be generated. That circumference of that circle is, or path of that circumference, path of the circle generated by revolution of the centroid. Okay, by circle generated by the centroid of the closed curve about the straight line. Okay, so that is this is the question here. 2s into 2 pi by 2 pi by bar is the circumference of the circle generated by the centroid about this line. Okay, and s is the area of the closed curve. This s we have taken as the area of the closed curve. Okay, so that is the first theorem, first question, which is first theorem of Pappus and Guldin. Pappus and Guldin theorem is this first theorem I have taken as first, or second is second, no problem. Second is of surface area theorem, which is also given by Guldin and Pappus and Guldin theorem known as. Okay, so that let me take now. Now Pappus and Guldin theorem, second one, based on surface area theorem, which is known as area theorem. Let me take the second question here now. Now here second theorem, which is surface theorem or area theorem known as Pappus and Guldin theorem. Now second theorem is the second theorem now. Second question, which says if an arc of the curve revolves about a straight line. This is if an arc of a curve revolves about a straight line, revolves about a straight line. This is written there. I'm just stating again about a straight line which does not intersect this arc. Okay, if an arc of a curve revolves about a straight line in its plane, a straight line in its plane, which does not intersect it, 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 yeah, which does not intersect it, then does not intersect it, the surface generated, then the surface generated by revolution of this arc about the straight line is equal to, then the surface generated is equal to the length of the arc multiplied by the circumference of the circle generated by the center of the arc. Simple. Is equal to surface generated by this revolution. If an arc of a curve revolves about that, I have already written down. So generated is equal to, we can write, then surface generated is equal to, that's the point, is equal to the length of the arc, is equal to the length of the arc, equal to the length of the arc into, or multiplied by length of the arc multiplied by, let me write, multiplied by or into circumference of the circle, circumference of the circle, generated by its centroid. Sorry, centroid. Okay, circle generated by the centroid of the arc, generated by the centroid of the arc. This is the second theorem, centroid of the arc. Now let me take an arc here. Okay, if I take an arc here, let me take, this is the arc. This is the arc here, or let me clearly write it down. This is the arc here. Let me take, this is A point, this is B point here. And let me join these 2 points, the axis of x. Okay, and these axes again, I have to take these exercises. This is x-axis here. Okay, again this is x equal to A, and here x equal to B at this point. So this is AL, I have taken again. Let me take this point is this M point is here. So BM, Okay, BM is at x equal to A, this is x equal to B. Okay, now if I take a centroid of this, let me take G is the centroid. If I draw a perpendicular from this is bi bar here, again the length of the centroid, so this is L, let me take L, I've taken M, N, let me take. Okay, so then, okay, and if I take P point here upon this, so this is GN, I've taken as the bi bar. Okay, length of the arc here, that is the length of the arc here, and then second point if I take, okay, so this is bi bar and G. Now therefore, we know that centroid, the centroid is given to us. Now solution, let me find out. This let me prove. If G is the centroid here, G is the x bar bi bar, let me take, this is x bar and bi bar. If AL be the arc, AL length of the arc is L, let me take, this is L here, length of the arc. If AL be the arc of length L, of length small l, where AL and BM be the abscissa or be the abscissae having x equal to A at AL and x equal to B at BM, again where B small b is greater than A. In this case, A to B we will take the limits because B is upper limit and this B is greater than A. And this length O, let me take, this is x by and by dash, this x dash here. Okay. Now we know that what is the centroid of this bi bar of an arc here. G be the centroid we have taken. If G x bar bi bar be the centroid, of this arc AB, of this arc AB, then from centroid we know that bi bar is equal to how much? We know that bi bar is equal to y into ds, limits A to B upon L here. This is y into ds, length, where y is the y coordinate of the point P at any point P here. So here y is length of the y coordinate of any point P. If I take P point here, let me take P point here, which is x and y coordinate. So this length of this P point is y here. Sorry, this is y here. Y coordinate of this is x up to this point. Okay, up to this point. This is P M N. Okay, let me take here R. PR. So PR is y here. So this we know about, this y into ds. This is what? Length of the arc here. Surface area, this length of the arc if revolves about this line, and this G is the centroid. The centroid is revolving about this line. Then centroid length of the centroid bi bar is given by this by into ds, and this is value. So by into ds is given to us. Okay, this is by into x equal to A to B here, by into ds. That means where L is the length of the, here L I have divided, so L is length which I have already written here. Here L is the length of the arc, where L now divided by length of the arc. In previous question, here was area because we were calculating volume. So in case of volume we have to divide by area, or that area was given here. Total area was given here in the numerator, and divided by elementary area in the denominator of area of the closed. Now here it is the length of the arc, in this case length of the arc L. where L is the length of the arc. This I have already written. Length of the L is the length of the arc AB. Of the arc AB. In this case, AB is the arc. Now this is there. Now what is the area? Surface area. What the surface area then? And also we know that this is. Let me take. Now in this case, we have first calculated centroid. This is centroid by bar. This is, let me take first equation. Also, surface area. This is surface area we are calculating. Also, surface area. Surface area of an arc. Surface area of an arc. Arc revolved about. Surface area of an arc revolved about a line, in this case a straight line, about a straight line, So here by L is equal to this value. Here I further let me, this is by into L into A to B y into ds. This is what? This value. Now we know that what is the surface area. Also the surface area of an arc revolved about a straight line is given by, this is 2 pi into y into ds, A to B length. This is 2 pi y into ds. Why? Because this is circumference type, or 2 pi into y into ds type. Or this can be written as 2 pi, let me take out. This is A to B into y into ds. This we know about. Here y is the y distance of P point. Because this arc is revolved about this hole, then that area will be generated and is given by 2 pi into y, because that area of that ring obtained by revolution of this arc will be the circumference into on this area. 2 pi y is the circumference into ds. ds is the length of this PQ if I take point, and if I take elementary PQ, elementary strip, that elementary strip is revolved about this line. Then we were talking about that this 2 pi y into ds, then area between A to B length, total area will be then calculated. That total area is calculated like this: 2 pi y into A into ds. This is first equation. Sorry, this is second now. First we have taken this. What do we see here? This y into ds, A to B limit, which is this, sorry, equal to. Therefore, y bar into L is equal to this. Y bar into L multiplied, cross multiplication. By in place of limit A to B by into ds, sign of integration, limit A to B by into ds, in this place we can write by into L. Let me write it here. So from first and second, let me write here. So from first and second equation, what do we get? We get here this surface area or area of revolution, surface area or area of the surface. Let me write here, area of the surface generated by revolution of arc, revolution of arc AB in this case, is equal to this value I am writing first in second equation. This is 2 pi into y into L, because this value A to B by into ds is by into L. This is by bar into L. Okay, so now let me write it here. Therefore, finally what do we get? Therefore, the surface area of revolution, therefore surface area of revolution of arc, revolution of the arc AB in this case, is equal to this, we have to write here 2 pi. That means if I write here L separate into 2 pi into y bar, 2 pi into y bar into L, or L into 2 pi bar into L. This is length of the arc, L is, that means length of the arc into multiplied by, this is circumference, 2 pi y is circumference of the circle, generated by the centroid of it, by the centroid of this arc, by the centroid. Circumference of the circle is generated by the centroid of the arc, in this case of the arc, centroid of the arc. So this is the formula. Length of the arc, L is length of the arc, into 2 pi by bar is circumference of the circle generated by the revolution of this G about this line. This ring will be obtained. That circumference of this ring is 2 pi into y bar. Y bar is this radius, in this case radius of this ring. Okay, that ring. So this is the second theorem. Now these two theorems are to be used to find out the further questions. Let me take. Now question number 3, let me discuss about. What is question number 3 say? Let me now check it. Question number 3 and the other questions are based on these two theorems. Let me discuss about. Okay, now question number 3. These two theorems were known as Pappus and Guldin theorem, or Guldinus theorems. Pappus and Guldinus theorems. Okay, Pappus and Guldin theorem or Pappus and Guldinus theorem. These two theorems are very important just to find out. These are not centroid theorems or volume and surface revolution theorems. Okay, including the centroid. So that is the centroid. Now question number 3 says, find the volume and surface area of the anchor ring generated by the revolution of a circle of radius a about an axis in its own plane, distance b from its center, where b is greater than a. It says where b is greater than a. Now it says find the volume and surface area of the anchor ring. There is anchor ring which is generated by revolution of a circle of radius a about an axis in its own plane, distance b from its center. Now distance b is of the from the center of the circle. So let me take this curve here like this. Okay, this is question number 3 here. I will say, and the volume and surface area of the anchor ring generated by the revolution of a circle of radius a. Now let me take this circle is this. Now here is the center. G is a centered also, because circle is having a closed circle like this. Now this circle will have the center as well as the G, the centroid of this same. If I drop this perpendicular from this, now this is equal to B here. B is greater than A, it is said. This is radius of this, radius of the circle here below. Okay, radius of the circle is this, and this is x-axis. Let me take, this is y-axis, y-dash axis, x-dash. This circle here we have taken. Now this circle is revolved about this straight line. Let me take OX, the x-axis, and then an anchor ring is generated. It says then find the volume and surface area. Find the volume and surface area of the anchor ring generated by the revolution of a circle of radius a about an axis in its own plane, distance b. That axis is distance b from its center. Center to this point is b, distance b away from this. This is b here. Okay, so G, let me take L point here. GL or LG, here LG equal to B. B is greater than A, the radius. Here A is the radius of the circle. A is the radius of the circle. This is the point here we are given. Now let me find the solution. Here. Now what is the surface area and this, all these things, let me discuss about them. Okay, so that is the point we have to discuss about. Now we know that what is the circumference of the circle of this case. So what is the, if I apply both the things, then the area of the circle is pi a square in this case, because radius is the a. So what is the, we can just find out with the help of, Guldin theorem or Pappus and Guldin theorem. So area, let me write here. Here the circle is, let me take x square by square. If I draw, is having radius a, is having a radius a. Therefore, volume of, first, what is the area of the circle? Let me first find area of the circle. So area of the circle, area of the circle is equal to pi into a pi r square or pi a square. This is first equation. And its circumference or length of the whole circle, its length or circumference, and circumference of the circle, or circumference of the circle, because here circumference, length of the arc is circumference of the circle is equal to 2 pi into a. This is the second equation that we take. Now volume, therefore volume given by, first is volume, we have to find out, therefore volume of revolution, they say, and the volume and surface area of anchor ring. Therefore volume of the anchor ring, generated by revolution, of a circle, revolution of the circle in this case, of the circle of radius a. Okay, we have to find out. So this is equal to, we know that this is equal to area of the circle into circumference of the circle generated by the centroid, by the